Today we are going to do section 2.5 on page 135. So first thing I should mention is the what is this called? The zero product property. Now, what happens is if you have two numbers that multiply to become zero, such as a times b equal to 0, how can two numbers become zero like that? The only possibility is if at least one of them is 0. Okay, because if two numbers are not 0, they're not going to multiply to become 0, because that would be odd. So the zero property states that if a times b is 0, then one of them had better be 0, at least. Maybe both, but at least one of them. Now, having said that, we are going to look at the second degree polynomial, which we have seen many times. Okay, a second degree polynomial is have three numbers a, b, c, and one variable x. So we have x squared. That's why it's called a second degree. So x at the highest power is squared. So x squared plus x, and then a number. So generally speaking, we call it ax squared plus bx plus c. And that polynomial has a name. It's called the quadratic equation. And in this section, we're going to focus on how to solve the quadratic equation. That is when that polynomial equals to 0. And so let's look at an example as a result. Okay, example 1. We have some kind of a quadratic equation, and it is set to 0. So example 1 on the following page. So now we are on page 136. And let's consider example 1. Example 1 states that we have quadratic equation, which is x squared plus x minus 6, and that equals 0. The way to solve most quadratic equations, the easy ones, is that you factor them. The same factoring trick that we learned in the previous the previous chapter where we learned how to factor. If you don't remember how to do this, please review that the factoring section because it's extremely important. Okay, and practice doing it again until you're good at factoring. Now, specifically for the quadratic equation, we have to come up with something that's such that when they multiply together, it gets this thing back exactly again. So how will we do that? So to factor this thing, there's a standard trick to it. That is, you have x right here, right? We have to have two x's to become x squared. And then we have to have something multiplied together to become 6. Now, what multiplies to become 6 is either 1 times 6 or some kind of a 2 times 3. The problem here is if we choose 1 times 6, then it's not going to come up with 5, because somehow the 1 plus 6 or 1 minus 6 has to become the thing in the middle. So we'll choose the second one, 2 times 3, because 2 times 3 does equal to 6, and then and 3 minus 2 becomes 1. Okay, so that's what we're going to do. We're going to choose 2 and 3. So that takes care of the 6, but it has to be negative, so they have to have different signs, either minus 2 plus 3 or plus 2 and minus 3. And being that this x is positive, so we'll choose make 3 the positive, and then 2 the negative. And then we're going to double check this thing. This thing multiplies, when we multiply this thing out, we have x times x is x squared, okay? And then we have minus 2x, right? So that's minus 2x, and then plus 3x. So plus 3x, and then finally this is minus 6. So all terms are accounted for. And as you notice, when you multiply stuff out, and the minus 2 and plus 3 end up being a plus 1, and that's how we come up with a quadratic equation. And so we know that our choice here is correct. As you can see, our choice here is just a guess, okay? What if there's no guesses? If there's no guarantee that you can come up with a guess for any old quadratic equation. However, right now we're only focusing on the ones that has easy guesses, okay? When you have just a 6, so either 2 times is it has to be either 1 times 6 or 2 times 3, and you make it come out and see which one will end up being a plus here. And that's how we solve this type of equation for the moment. Now, if this trick doesn't work, if you exhausted all your options and still can't come up with something that's exactly the same, then we have a different trick for hunting the for factoring this thing. And by then, it is the different trick is more involved, and we will see that in a moment. But for now, let's live on the easy life, okay? And just come out with something. We'll have the easiest problems where the trick does work, and then we'll come up with the answer this way with just really one step. So that's example 1. Please do that as part of your homework. Now, you might find it difficult to come up with this stuff at first, but after quite a bit of practice, then you can get faster and faster at seeing what multiplies together. So let's, as a demonstration, let's do a second example, example 2. All right, before I mention that, let's look at the following page. Now we're on page 137. 37, where you see this thing, right, this equation right here being graphed. Okay, that is the graph of it. If you are to, that's not the equation equal to 0 though, that's just the equation when it equals to y. It equals to 0 when it crosses the x-axis right here. Okay, and as you can see, it crosses the axis where at -3, 0, and 2, 0. That is there's a reason for that. That's how our -2 and 3 are related. But we'll talk about that later. Actually, before I finish, I need to talk about that now. I forgot what I was doing. And we're not just factoring here. We're actually solving the equation. So let's continue. Now, because this multiplies by to be 0, then one of them has to be 0, because we have 2 items being multiplied and they equal to 0, so one of them had better be 0. Okay, so the possibility is each one might be 0. Now, so the first one, if the first one is set to 0, if x minus 2 equal to 0, that means x has to be equal to 2. And then if x plus 3 is 0, then x then equals to -3, because we can kick the 2 to the other side of the equation by changing the sign. Similarly with the plus 3, if put it on the other side of the equation is -3. So as a result, we have, this is the solution, okay? I got carried away with factoring, forgot what we're doing here. So the solution is x is 2 or x is -3, and that's how we solve the quadratic equation. That's why on the following page 137, when we plot the quadratic equation, quadratic expression here, and then we get, see, it crosses the axis at -3 or +2. Just like it says, it's either +2 or -3 that the quadratic equation crosses the x-axis, or the quadratic formula. Because it's an equation when it's set to 0. But generally speaking, just this expression here, that's just a quadratic something. Now, I can't even remember what it's called. I'll remember later. Let's move on. Now, let's look at example 2, which is the same thing. We are going to solve some quadratic equation. And let's see. So now let's look at example 2. I will write it down here. So example 2, we have x squared, and then plus 8x plus 15. And that equals to 0. Now, again, we'll pull this trick and then hope for the best, okay? If it's an easy problem, then we'll be able to come up with something. We have to have there's only x here, so we can write that down, okay? So x times x will become x squared. Now, the 15, what multiplies together to become 15? Is either 1 times 15 or 3 times 5. Now, notice 3 times 5 is convenient because 3 plus 5 does equal to 8, okay? So that's what we're going to choose. We'll choose 3 and 5, and that will become 15. And in the meantime, 3x plus the 5x will become 8. So that is nice and convenient, and that is our factoring. Now, once we got the factoring, remember the zero product property or something? If two things are multiplied and become zero, one of them had better be zero. Okay, so with the choices are that either x plus 3 equals to 0, in which case x then equal to 3, negative 3, or x plus 5 equal to 0, or in which case x is equal to minus 5. That is our two options for this thing, and that should be it. Okay, and then next, let's look at example 3. Example 3, what is the problem? Okay, it has a difference of squares. The difference of squares problem is x squared, in this case x squared minus 9 equal to 0. This is example 3, okay, on the following page. We have, and then this thing, whenever you see the two squares being subtracted, then you always remember this good old formula, okay, that which is a squared minus b squared equals to a plus b times a minus b. This is an extremely important formula that will be seen all the time. So if you don't remember it, you will. And therefore x squared minus 9, then we factor it just like it says, then it will become x minus 3, okay, take the square root of both items, and then do a plus and do a minus. Plus 3, and that will equal to 0, and that is the factoring of this expression, which then gives us from here, we have each item then has to be 0, okay, to be able to make this make sense. Therefore, either x minus 3 equal to 0, which gives us x equal to positive 3 by pushing the negative 3 to the other side. Similarly, x plus 3 equal to 0. That's the second one over here. And then we have x then equal to negative 3 by kicking the 3 to the other side of the equation and changing the sign. And that should be the answer to example 3. Now, example 4, we have a more difficult problem. So far, our problems have x's with nothing in front, no numbers in front of the x. Now, what if we have a number in front of the x? So let's look at example 4. Now, example 4, where we have a case where we have some kind of a thing in front of the x, and things get harder when that happens. When there's a number in front of the x, then the factoring gets has too many options and can become more difficult. But for now, let's hope that this is an easy one, okay? And we have to come up with something. Then multiply equal to 0. Now, what might it be? So the x's can either be 1, 4 or 2, 2, okay? And then right here, so we have the options here include 1, 4 or 1, 4. 4 is on the other side. 1 times 4 is 4, okay? And then 2 times 2 is 2. So these are our options. Now, in the meantime, the options here includes 1 and 9, and then 3 and 3, right? These are the various options for these things, are the numbers on the side. Now, so we'll write down x here, but we don't know how many x. Okay, what's the number in front of x? That's the trick. So if we have 1 times 4 and then 1 times 9, that would be 4 plus 9 is 13. That's not good enough, okay? So we have 2 times 2 and then 1 times 9. Then we have, let's see, 2 times, all right, so the possibilities I wrote down is still not quite good enough, okay? We need to switch it around because this can be either 1 times 4 or the other way around. There's also a possibility of 4 times 1. And then this one can also be 9 times 1. So these are all the possible combinations. Then we stare at this thing and hope that we can come up with 15 out of it. Luckily, everything is positive so that we don't have to think about subtraction. So after some trial and error, we know that the 4 times, eventually what we get is that 4 times 3 if we choose the 4 option, okay, and the 3 option, so then 4 times 3 is 12, plus 3 is plus the 3 times 1. Where is it? Let me write this down. Okay, and then 1 times 3 is 15. It's easier to just do this than explain it, okay? So, but anyway, so we have, let's write that down, see what happens. 4 times 3 is 12, okay? And then, and then we have, this is 3 times 1. So when you add all this stuff together, so then 4 times 3 is 12, plus 3 is 15, and we get the 15. In the meantime, 4 times 1 is 4, and then 3 times 3 is 9, so the whole thing works out. So let's then come up with the answer. The answer is then 4x plus 3 equals to 0, okay, by the zero product property, which gives us x equals to, push the 3 to the other side, that better be negative, and then divide by 4, so that becomes negative 3 over 4. The 4, remember, we push it down across the equal sign to below the below the division line. Similarly, if x plus 3 equal to 0, then x equals to minus 3. Okay, is that the answer? Let's double check this thing. Minus 3 and minus 3/4. So that is correct. All right, and then if we were to graph this thing, then we have graph this equation where is y equal to 4x squared plus 15x plus 9. If we set y equal to 0, as you notice that it will hit the x-axis at those two values, at minus 3/4, okay, and at negative 3, as we can see. So the graphing can be done easily nowadays on the Desmos graphing calculator, and it creates a beautiful graph. All you have to do is just type in the equation. We are not going to do much graphing in this section, but we will be in future sections. Okay, so let me clean off the board. Next, let's do example 5 on page 139. We now have something that's not a quadratic equation. And it has a third power. However, this happens to not have a constant here. There's no number at the end. See, as third, second, first, and no number. Okay, so which means we can take advantage of that fact by turning this into a quadratic that look like a quadratic equation by factoring out some x. In fact, we'll also factor out the negative sign as well. Okay, because we don't like negative signs, so we'll take it out. So then we'll take out the negative x, both, and so what we have left is just positive x squared. Okay, the reason this works is if you multiply this by this, then you will get the negative 3x cubed back. Similarly, in here, we'll take out a negative x, so we end up with a positive 5x. And lastly, we have pull out the negative x, we only have positive 2 left. So that equal to 0. Now at this point, you know that the solution to this equation, the first solution, is that x equal to 0. That is a solution, which I'll write right here. So x equal to 0 is automatically a solution, because if x is equal to 0, then this whole thing goes to 0 by the zero product property that we learned a little bit earlier. So the first solution is x equal to 0 before you do anything else, okay? And when x is 0, this whole thing will be multiplied and become 0, period. So next option is that if we have this thing equal to 0, so here's the other option, 3x squared plus 5x plus 2 equal to 0. Okay, now here is the quadratic equation that we are about to solve. So let's pull that trick again. Okay, and do this. Well, we need to come up with something that multiplies to become that. It's that simple. Okay, we are going to hope for the best. So that is everything is positive in this case, because we factored out the negative sign. So then we can safely put a positive sign here, because there's no way there's a negative sign here and still end up being positive in both cases. Okay, it's positive to have a negative sign in here and be positive in one case, but but I don't think it's possible to be negative and then turns out, yeah, if it's negative here and positive here, then this number will be negative, okay, because that's where this comes from. So it has to be both positive, which makes things a little bit easier. So this has to be 1 or 2, and one of them has to be 2, and the other one has to be positive 1. And then, so now we have to figure out one of them. So we have to come up with 5. So it will be 3 plus 2 is 5. So we'll write down the 3 right here. Okay, it's a matter of your trial and error and hope to come out. Okay, so then if you have trouble doing this kind of thing, you just keep trying different options. You have only so many options, which might be time consuming, but you can get it done. So that's how we do this. And then as a result, then we have this equal to 0, okay, by the rules. So 3x plus 2 equal to 0, which gives us, then we push the x to the other side, becomes negative 2. Sorry, push the 2 to the other side, become negative 2. And then push the 3 down below the division line. And so x equal to negative over 3. The next possibility, x plus 1 equal to 0, and then that gives us push the 1 to the other side of the equal sign, x equal to minus 1. By changing the sign, you always do that. So these should be our three solutions. The first one is here, okay? First solution, second solution, third solution. And that should be right. Let's check. What are the solutions? Okay, so then we have x equal to 0, x equal to negative 2/3, and x equal to minus 1 on the following page. So we are good, okay? And this next we used something like if some property on this page. We are now on the, let's see, I can't find the page 140, where there is a thing that we should mention. That is, if something squared equals to a number, okay, and then we can directly solve the equation. X will be the positive or negative of the square root. That is, for example, x squared equals to 9, which we did a little bit earlier. Then x has to be a positive 3 or negative 3, because either one, when you square them, becomes 9. Okay, so normally when you solve the square of something, you will have two answers: the positive root, the positive answer, and the negative answer. And both are acceptable, okay? And sometimes in word problems, of course, the negative answer often doesn't make sense, so then we throw it away. But however, the negative answer is possible, at least in theory. That is, for example, if you say x squared equals to 9, then of course x can be 3, but x can also be negative 3, because negative 3 squared also becomes positive 9. So then let's look at an example, such as example 6, and that's x squared equals to 8. Well, if x squared equals to 8, then x will be the square root of 8 or the negative square root of 8. And you can also simplify that fact and the square root of 8 by making it into 2 square root of 2. So then if x squared equals to 8, we'll take the square root, okay, as the rule says, but we'll put a plus minus sign in front. That means this is a shorthand. That means x equal to plus square root of 8 and x equal to minus square root of 8. Both solutions are valid. So we'll be lazy and just write it all in one sentence. So that's what this symbol means. It can be either plus or it can be minus. So then we'll simplify the radical. If you don't remember how to do this, please refer to chapter 1, where there's an entire section on how to simplify radicals. It's very important that you know how to do this. Okay, so then we have the square root of 8 that will become factored out, becomes square root of 4 times 2. So the square root of 4 is just 2. We can take that out. And the square root of 2, there's nothing we can do about that. So then x equal to 2 square root of 2, and there's a plus or minus sign in here. Okay, so that just means x equal to either equal to the positive one or the negative one. And both ones are acceptable in this problem. So as your book says, the solutions are 2 square root of 2 or negative 2 square root of 2. So let's look at the next page, example 7. By the way, please do all the examples that we have covered, and I've also listed the examples that you need to redo under the video. The trick to being good at algebra or good at math in general is by doing all the examples, okay? Because that solidifies the knowledge in your mind, and not just by watching the professor do it. Because it's like playing basketball. Watching the guy play is not going to get you much better at playing yourself, if at all, okay? Because anybody can watch somebody else play. Let's see you play, right? So please be sure to do all the examples that I assign to be done as part of your homework as well. So you do it by not looking at the solution, okay? And just try to do it. See if you can do it yourself. If you can, then that's done. Let's move on. So example 7, what are we doing here? Okay, so we have a question, 4x squared plus 1 equals to 7. So that is strictly speaking a quadratic equation because the highest power is 2, but in reality it's not much of a quadratic equation because we can solve it very quickly. Okay, so then we have 4x squared equals to 7 minus 1. That's 6. Okay, push the 1 to the other side, becomes a subtraction. And then, so x squared equals to 6 over 4. Simplifies to push the 4 across the equation sign, under the division sign. So then that is 3 over 2. So then x is, as we have discussed, x then equals to the square root of 3 over 2. That is, all right. All right, so then actually maybe we should just keep it this way, okay? We'll call it square root of 6 over 4. That might be better. Let's call this thing the square root of something. All right, square root of 6 over 4, not even simplify it. And because then we get just the square root of 6, and square root of 4 can be simplified into 2. Now remember, the square root sign can be split up like this. Again, this is taught in chapter 1 under the radical expressions section. If you have any puzzlement about how to do this, please review chapter 1, this section about radical signs. It's extremely important, okay, that you know all this stuff. You know chapter 1 by like the back of your hand. Okay, so let's move on. And so x equal to this thing. And being that we're taking the square root, don't forget the plus and minus symbol. That means both the plus 1 and the minus 1, the negative 1, are acceptable solutions. So as your book says, the solutions are square root of 6 over 2 and negative square root 6 over 2. And they're both solutions, and you must not forget either one of them. Now, next, let's do something called completing the square. Now, that is a bit more involved, but straightforward if you follow the steps exactly. Okay, so now we are going to pull some stunt called completing the square. It's an important skill to memorize because this will be done in algebra and then in trigonometry. I don't know about trigonometry, but I know it will be mentioned again in Precalculus if you are planning on going on in your math. So completing the square is a skill that that you should be. You should memorize how to do this, is what I'm trying to say. So let's look at completing the square. So we have, let's look at the example here on this page. Where are we right now? Page 141. I'll write it here. Page 141, and we have this thing that's called x squared plus 4x plus 1 equal to 0. Now that solution cannot be factored. That's because this middle thing is too big, okay? If you were to factor it, you have something like this, okay? And then equal to 0. And what do you have? X only has 1 as a coefficient. There's only 1 here. So of necessity, it has to be 1. And the final result is only 1, so you can only have 1 here, okay? And being that everything is plus, then you have no choice but to slap on the plus. But this thing only becomes x squared plus 2x plus 1, right? If you multiply it out. So there's so this thing cannot be factored like the trick that we've been using. That's because this is a more difficult problem. So that's why we're gonna slap complete the square trick on this thing, okay? So the completing the square is a bunch of steps, like following a recipe when you cook. You follow the steps, and then will outcome some answer. First, we have to kick the number to the other side. So we have x squared plus 4x equals to minus 1. And so far, so good. The second step is we are going to take the half of this number and square it, okay? So we have x squared plus 4x, half of 4, and then squared is equal to 4. Now, why are we doing that? Because we want to make this into a perfect square. Just this part, okay? So if you plus 4, then this will become a perfect square. And in the meantime, we will plus 4 on the other side to be fair. Okay, so far I have added 4 on both sides of the equation, so I haven't changed anything. Now there's a purpose to doing this, because this will make this thing into a perfect square. Well, by that I mean when you factor this thing, it will become exactly x plus 2 times itself. Okay, that's what a perfect square is. So when you multiply this out, you know, that's x squared, right? Plus 2x plus another 2x, that's 4x, and then 2 times 2 is 4. So that this will come out to be exactly this part. Now on this side, we have so we have minus 1 plus 4, then it becomes a 3. All right, so by now we have a perfect square here, and what we're gonna do is this trick right here. When you have we have two things that multiplied by themselves equals a positive 3. That means that x plus 2 is going to be equal to the square root of 3. Okay, the positive square root or the negative one. So we'll be lazy and write it like this. So that means we're taking the square root, right? Because I mean this is a perfect square, so it's fair enough to do that. And then as a result, then we have x then equal to this. We'll push the plus 2 to the other side, becomes negative 2. Okay, and then we'll have the plus or minus square root of 3 here. Remember, that means this positive or negative 1. Another way of writing this is that you write it into 2 equations. So the answer is x equals to minus 2 plus square root of 3, or that's a plus sign, or x equal to minus 2 and then minus square root of 3. That's the other way of writing it. If you don't want to be lazy, because plus or minus might look a bit confusing, you can write it out like this, and that is not so confusing. It just means that x has 2 answers. Okay, either the plus 1 or the negative 1. Or you can be lazy and write it like this. And I like the lazy way. So then you don't have to do as much writing. But this process right here is called completing the square. That's because you turn this thing into a perfect square, okay, something multiplied by itself. And as a result, you can take the square root directly. Now to do that, there's only one trick to this, is that you take the number in front of x, okay, in your quadratic equation, assuming that there's only 1 here. Okay, there's no number here because it's just 1. Then you can pull this trick. So you take this number divided by half, okay, and that is the number that you're going to multiply by. And then when the number multiplied by itself, that is going to be the 4 here, and you have to add it to both sides. And once you've done that, then the process comes out very nicely. See, and as a result, you notice that even though we couldn't factor this, okay, it doesn't factor. And so we couldn't get the solution that way. We got the solution anyway. We got this very interesting, odd-looking solution with a square root in it. But it does work. See, the whole thing makes logical sense. So, all right. So let's do an example after I clean off the board. All right, now let's look at example 8, where we're going to pull the same trick that we just did. However, this will be slightly more difficult because this thing doesn't divide by 2 easily. And so we're going to have to deal with fractions. Now, if you have any trouble dealing with fractions, please look at the last section of chapter 1 and work on it until you're good at it, okay? It's extremely important that you're good at fractions, or basically any other part of chapter 1. It's the review chapter, and I expect you to know every bit about it, okay? Inside out. Very important. So now let's look at this thing. We have, we'll try to complete the square trick again. So what we're gonna do, again, this thing, I don't think you can even do this. I mean, if you were to factor it like we normally do, okay, right, this thing, what are you gonna have? You're gonna have x here, okay, because x has only one power. And then you have 5, which only factors into 1 and 5. And 1 and 5, no matter what one of them has to be negative, okay? So the 5 better be negative because you have a negative 3 in the middle. So this one has to be positive, and the most you're going to get out of it is x squared, see, minus 4x plus minus 5, right? You're not going to get the negative 3x. It's just, there's no way to do that way. So that's why we're going to do the complete the square trick. So to do the complete the square, we are going to do the same thing we did before, which is we'll take x squared, okay, and then minus 3x, we'll write it down, and we'll write down the 5 on the other side of the equal sign, which is just become positive 5. So far so good. Next, we're going to take the half of this thing, okay, and then square it, which is, so half of 3, and then square it. And that will make this into a perfect square, because what this is just this part, okay, not counting the 5. And of course, we better not forget to do the same thing on the other side to be fair, okay. So far, we have added this odd fraction to both sides of the equation. So we haven't changed anything. The equation still holds. Now, having said that, let's do this. So that will become x minus 3/2. Okay, because whatever you took the half of and squared, that will be the answer in this part of the factoring. So let's 3/2, okay? And if you double check, when you multiply this out, it will become x squared, okay? Then you have 2 of minus 3/2 x, so it's just negative 3x. And then this times that is just that thing squared. So this will work out to be exactly that. Now in the meantime, we have to do fraction on this side. What's that? That is, we'll call it over, everything over 4, okay? 5 times 4 is 20. So we have 20 over here, and then plus 9 here, okay? So that end up with an odd fraction for us, but we'll deal with that later. Now continuing, this become a perfect square. That means we can take the square root like we did before. So one of them, x minus 3/2, is going to be equal to this thing. Take the square root of this thing, which is 29, which is a prime number, okay, the lovely prime numbers we learned earlier, divide by 4, all right. So then, so that there's that, and so eventually then we get x, then move the negative 3/2 to the other side, becomes positive, and so we have positive 3/2. Okay, and in the meantime, I will write that as 29 on top, but take the square root of 4 on the bottom, so it has only 2 left. And then we remember there's a plus and minus sign when we take the square root, okay? Because both the plus version and the negative version works. So there's the plus and minus sign there. And that is our answer. Our answer is either plus of this thing, this awkward looking thing, or the negative of this thing, equally awkward. Okay, and that is our answer. So that, which is why we can't factor it. There's no way we can, come up with that thing just by messing over there. But by doing this trick, by called completing the squares, we can totally come up with the odd answer. All right, so that is that. Now the next thing we are going to do is summarize what we did here in symbolic form. Okay, so how does completing the squares normally work with any kind of quadratic equation? And so now I'm at the bottom of our page, okay, where we are looking at something called the quadratic formula, and we're going to develop it the same way we do here. Now to develop the quadratic formula, we have ax squared plus, we have ax squared plus bx plus c, which is the general form for the quadratic equation. Ax squared plus bx plus c equals to 0. All right. That's our equation. Now, in that case, well, being that it's a quadratic equation, a is not 0, because if a is 0, then we don't have a problem, right? We just have that. So a is not 0 and that's just something we like to say to be clear what we're talking about. So then if a is not 0, then we can do the completing the square first by dividing everything with a. So let's divide across the board with a. So we have just x squared left. We divide by a and then divide by a. So we got 2 here, okay? And the second step is we are going to do the complete this, kick that thing to the other side. So we have x squared plus b over ax equal to negative c over a. Now at this point, we're dealing with quite a bit of symbols, and some people, when they see too many symbols, they want to shut down, say, that looks too hard, I don't want to do it. But in reality, the symbols are not different than what we just did, okay? The symbols just represent the numbers. So if you find it difficult, you can just pretend that b is, I don't know, 3 or something. Pretend it's something. Then you can see it better. Okay, but in the end, symbols are no different than numbers. Either way, they are just just a thing there that you're supposed to work with, and we're going to work with it the same way as we always do, at the same way as we did in this case. So let's deal with this. To complete the square, the first thing is the coefficient in front of x. We're going to take half of it. Okay, and then so we have x squared plus b over ax. We'll take half of b over a, so it becomes b over 2a, right? That's half of b over a. And then we are going to square it. And the reason for doing this is so that we make this into a perfect square. And to be fair, on the other side, we have minus c over a, and then we also plus a b over a squared. Now at this point, we're doing a bunch of expressions and what is this? I don't even remember what is the powers and all that stuff, which is again taught revealed in chapter 1. Please be sure that you know how to do this stuff, okay? And why this works, how to do power and divide and all those things. And review chapter 1 if you in the appropriate section if you have any trouble with this. And so let's continuing. We have this thing, so this perfects into x plus b over 2a, because if you have x plus b over 2a and you multiply it together, it will become exactly this, okay? Because then you have x squared, right? And then you have b over 2ax plus another b over 2ax, then it just becomes b over ax. And then the last thing is just this thing multiplied together. It factors out exactly like our previous example. And in the meantime, this side has that mess in there. We will clean it up a little bit, maybe, or not. What are we going to do with this? I'll think about it later, okay? E equals to this thing. So I'll just point to it. And, oh, right. There's a b, it's b over 2a. I missed the b, the 2. That's why it looked weird. Okay, that's better. I hope you recognize that that's a 2a. And we'll deal with that in a moment. In the meantime, we will do this, okay? Yeah, so then we'll have to take the square root. So we have x plus b over 2a squared. I'll rewrite this thing as a squared. And yeah, can't get out of doing that. So let's do that. Okay, so that becomes what? We simplify that expression by letting the 2a, okay, which becomes 4a squared, as the common denominator for both items. So if we have 4a squared down here, then the minus c will become minus 4a. Let's see, how would it be? Okay, let's see. multiply, to become that, we have to multiply by 4a, right? Because when you cancel the 4a out, you just have the c over a with a negative sign, right? Okay, so it's pretty good. And then plus b squared. So far so good. And then next, we will take the square root. Now we have a giant looking thing. So we have x plus b over 2a will be equal to the plus and minus of that mess, okay? That whole thing there. So minus 4ac plus b squared divided by 4a squared, all under square root. Now, at this point, you might feel like, that looks hard. It's not, okay? Just because you got more numbers, that you got more stuff, doesn't mean it's any harder than what we're doing right here. That it's kind of like washing 2 toilets instead of 1. It's more work, but it's not really harder. That is, if you can do 1 toilet, you can do 2 toilets, right? Just as long as you got enough time. And so, so then eventually, then we have this thing can simplify by into x then equal to negative b, okay, divided by 2a. We put the b over 2a to the other side, and then plus or minus, remember that means either one, plus or minus the square root of negative, don't forget that negative, 4ac. I'll write it the other direction. Okay, we'll write b squared first. Okay, so b squared minus 4ac and divided by, we'll take the square root of this, which also is 2a. We have a plus or minus sign there, so it's all good. So that is this thing right here is called the quadratic equation, where it has 2a on both sides of both equations. So we'll combine it into both fractions. So we'll combine it into one fraction. So finally, the quadratic equation as listed right here is how we came up with it. That is, the quadratic equation states that x equals to minus b plus or minus square root of b squared minus 4ac over 2a. Now please memorize the quadratic equation. When I was teaching at the university, I made my students memorize this thing, okay, by testing them on this equation every single day as a pop quiz. Well, what I did is every day I put the equation on the board and before the class starts, and the second the bell rings, I erase the board and tell them to, here's a pop quiz. What is this? Write down the quadratic equation, and you have to write it 100% correct. And after that, all my students knew how to do the quadratic equation. I mean, I did that every day for a week. So, which helps. I mean, anybody can memorize that. My point is, anybody can memorize this stuff if you, force them hard enough. So, and all my students memorized it, no exceptions. So please memorize the quadratic equation, okay? And then once you have it memorized, then let's look at example 9 after I erase the board. Now you might wonder, is the quadratic equation that useful? Not really. We use it sometimes. It's not that big a deal, but it's a cute little equation, and if you're going to study algebra, you might as well memorize that equation as good as any, okay? I mean, then that way, anybody who asks you, what is the quadratic formula, you immediately will say, well, a quadratic formula states that x equal to minus b plus or minus square root of b squared minus 4ac all over 2a, which sounds impressive. See? And we always want to sound impressive around here. So please memorize the quadratic formula. You just do it once a day until a week later you will have it down. So let's look at example 9, okay? Another problem that you cannot possibly do that trick of factoring, okay? The 2 parentheses is just not going to work because 5 is too big. So we're forced to do the, well, we don't have to do the completing the square now because the quadratic formula effectively did the completing the square for us. So we just have to plug it in. So plug it in. Let's memorize the quadratic formula, which states that x equals to minus b. Okay, remember what a, b, and c is. This is a, which is 1. Okay, b is 5, and c is 1. So quadratic equation states that the x equals to minus b, which is 5, plus or minus square root of b squared, 5 squared, that's 25, okay? B squared minus 4 times a, which is 1, 4 times 1 times c, another 1, all over 2 times a. 2 times a is 2, because a is just 1. And then you clean this up slightly. That's minus 5, okay? Plus or minus square root of 25 minus 4, which is 21. And then all divided by 2, and that should be our answer. Yep, negative 5 plus or minus square root of 21 over 2. And remember, the plus or minus is just a lazy way or a shorthand of saying the x equal to the plus 1 or x equal to the minus 1. And so that's our answer. And as you can see, this is actually faster in some cases than trying to factor or trying to complete the square or trying to whatever. So that is example 9. Please do that as part of your homework. Next, let's look at example 10, solving another quadratic equation with the quadratic formula. Let's write that down, problem 10 on the same page. X squared plus x plus 2 equal to 0. Now again, this one, if you were to factor it, you can't, okay? I mean, let's try factoring this thing. We have this thing, right? Now x squared is, well, it has to be x times x, right? And then 2 has to be 1 times 2. There's no other way. And then everything's plus, so you can't stick a negative sign in there. So everything has to be plus. Because if you have a negative sign in there in either one, then you have to, it will end up being somewhere going to be negative. Okay, I mean, this thing will be negative. And then, so anyways, but this doesn't become that, because that being the only option will end up being x plus 3, x squared plus 3x plus 2. That's what this is going to be, okay? When you multiply this thing out, see? X squared, right? Plus 1x plus 2 plus 2x, that's 3x. And then the final term is 2, and you can't, this cannot be factored with this way. So we have to pull out some quadratic formula. Let's pull this out. The quadratic formula, as you are supposed to memorize, okay, or look at it if you haven't memorized it yet, is a minus 1. So remember what a, b, and c is. That's a, that's b, and that's c. So a is 1, b is also 1, and c is 2. And so knowing that, so x equals to minus b, okay, plus or minus square root of b squared, that's 1, squared, still 1, minus 4 times a times 1 times c is 2, all over 2a. That would be equal to 1 plus, sorry, I shouldn't write down 2a, just 2, okay, because a is 1. And so that would be equal to minus 1, minus, and markers fainting. Okay, minus 1 plus or minus square root of 1 minus 4 times 2 is 8, so that's negative 7, okay, and over 2, negative all over 2. All right, so now you can see that being a square root, there's a chance that this thing just might be negative, especially you have a subtraction in the formula. In this case, it is. Let's check to see if I got it right. Did I make a mistake? No, that looks good. Yep, that is what the book says. The answer is minus 1 plus or minus square root of negative 7 over 2. Now remember what the square root of negative 7 is. You take is I times square root of negative 7, okay, is equal to negative 7 equals to square root of 7 times I from the complex numbers we learned in the previous section. So the answer here is, as you still have two answers, but they have i's in them. But other than the I, nothing's different, okay? We write down the I to stand for the square root of negative 1, and then the answer stands as is. And So which means that this equation has no real solution. That is, its solution is only imaginary and it has complex numbers in it, which is okay. All right. For at this moment, we don't care that is the fact. So as a result, and we just accept that and move on. All right. So then what was under the square root of the quadratic equation? Under the square root, it says something like this. The stuff under the square root is, or let's say the entire equation says the minus b, okay, plus or minus, right? That's a plus or minus sign. B squared minus 4ac over 2a. So that's the quadratic formula. X equal to that. Now, just the part under the square root sign will determine whether your answer is okay or not. That is your answer positive or negative? Now, let's say your answer, whether your answer is real or imaginary. That is, if the stuff under the square root sign is negative, then it is your answer is gonna have to be imaginary, which means that the stuff under the square root sign is important in determining whether you have a real or imaginary answer. So there's a name for this thing. It's called the discriminant. Okay, math always loves to pick up cute names from English, from literature, language, to describe something that might or might not have anything to do with the meaning of the word itself. So we will call this thing right here the discriminant. Okay, the b squared minus 4ac. So now it has a name. B squared minus 4ac will decide whether you have a real answer or imaginary answer. And also, it has if it equals to 0 completely, it will have one solution. Okay, the plus or minus option becomes 0. Okay, then you just have one answer to your quadratic equation. If the stuff equals to is bigger than 0, then we have two solutions. If it's the two solutions could be rational or irrational depending on whether this thing is a perfect square or not. That is, if you can take the square root of it. And finally, if it's less than 0, we have two complex or imaginary solutions. Anyway, so that is just something to be mentioned. Is in reality, we're just going to apply this and crank something out. Okay, basically, you just have to remember that if this value is positive, we get real answers. If it's real number answers, if it's negative, we get imaginary number answers. So having said that, let's look at. I think I will put in get to the end of this video for now. Okay, and finish the video tomorrow, where we will also be assigning the homework. So yes, so please continue this lesson in the next video.